Okay, first things first, we've got to build our foundation. And in Google Cloud Security, that foundation is Identity and Access Management. IAM. It really all boils down to one simple but super powerful question. Who can do what on which resource?
So, how does this work? Well, the whole system hangs on something called an IAM policy. The best way to think about it is like a little rule book that's attached to every single thing in Google Cloud. I mean everything, from a storage bucket to a virtual machine. And that rule book, it's the final say on who gets to do what.
Okay, so let's break that policy down. It's actually pretty simple. You've got three main parts. First up is the principal. That's just the who. Is it a person, a group, or maybe an application? Then you have the role. That's the what. What can they actually do? And then you can get super specific with an optional condition. This is the when or where, like only allow access from this location or only during work hours.
Now, this is something you are definitely going to see on the exam, choosing the right role. And the golden rule here is to always go for the specific predefined roles. These basic roles like owner or editor, they're just way too broad for production. You really have to live by the principle of least privilege, which just means give people and services only the permissions they absolutely need to do their job and nothing more.
Okay, so what happens when access doesn't work the way you expect? You'll need to know your tools. Remember these three. For a quick, why can't this person do this check? You've got the policy troubleshooter. For a big picture view of your entire organization, there's the policy analyzer. And to see the history of who did what and when, you'll dive into cloud audit logs. Quick tip for the exam, remember that admin activity logs are on by default, but you usually have to turn on the data access logs yourself.
All right, so we've talked about people, but what about our apps, our VMs? They need identities too, right? That's where service accounts come into play.
Okay, listen up because this is huge. I cannot say this enough. Do not use the default service account in production. Seriously. It gets the super powerful editor role by default, which is a gigantic security hole. Just imagine. Some simple web server gets compromised, and because it's using the default account, the attacker now has permission to nuke your production databases. It's a nightmare scenario. And that's exactly why proper automation for things like GKE or Cloud Run always creates a dedicated custom service account with just the bare minimum permissions needed.
So if you're using GKE, Google Kubernetes Engine, the absolute best practice, the gold standard, is something called workload identity. It is a really smart way for your applications running in Kubernetes pods to securely authenticate to other Google services without needing to handle any of those risky JSON key files. It's all done automatically and securely in the background. It just works, and it's how modern, secure GKE setups are built.
This brings us to another really cool and secure concept, impersonation. Think of it like this. Instead of giving a user permanent, powerful permissions, you let them temporarily wear the hat of a service account that does have those permissions. They can do what they need to do, and then the special access is gone. Everything they do is logged, and best of all, no static keys or long-term credentials floating around.
So, if there's one major theme here, it's this. Static keys are bad. Short-lived credentials are good. You have to get away from downloading those JSON key files that live forever and could get leaked. The modern, secure way is to generate credentials, like access tokens, that are only valid for a short time, maybe just a few minutes. It's a total game changer for security.
Okay, so our apps have secure identities. Great, but what about the sensitive stuff inside the apps? And how do we control who can even access them? Let's dive into securing apps and secrets.
Here's a scenario that every developer runs into. You've got database passwords, API keys, all that sensitive stuff. You know you can't check it into your code. That's a huge no-no. And just sticking them in environment variables isn't great either. So, what's the right way to handle this? And the answer you need to know for the exam and for your real-world projects is Secret Manager. It is literally a managed, secure vault designed specifically for this problem. You put your secrets in one central place, lock down access using the IAM principles we just talked about, and everything is audited. It's the clean, secure solution. And you'll want to know a few of its key features. It's more than just a place to store things. You can version your secrets, which is amazing for rollbacks. You can even set up automated rotation, so your passwords change on a schedule without you lifting a finger. This is the kind of stuff that modern applications, like those running on Cloud Run, are built to use, pulling secrets securely when they start up. Now, what about protecting the front door to your web apps? For that, you need to know about Identity Aware Proxy, or IAP. Think of it like a super smart security guard standing in front of your application.
It checks everyone's ID, their Google identity, before they're even allowed to knock on your app store. It's a zero-trust approach, and for many cases, it completely replaces the need for an old-school VPN.
But good security isn't just about the outer wall. You need internal walls too. That's defense in depth. Inside a Kubernetes cluster, GKE network policies are those internal walls. They're like a firewall between your different application components, or pods. This way, even if one part of your app gets compromised, it's trapped. It can't move sideways and attack everything else. It's a crucial layer of security.
All right, let's wrap up with a couple of more advanced topics that really complete the picture, taking control of your encryption keys and locking down access to your VMs.
So you should know that Google encrypts your data by default. That's great. But sometimes for compliance or just for extra control, you need to hold the keys yourself. That's where customer-managed encryption keys, or CMEK, come in. It means you control the encryption key in Cloud KMS. If you want to cut off all access to the data, you can just disable or destroy the key. It gives you the ultimate control.
Finally, let's talk about getting into your virtual machines. The old-school way was managing individual SSH key files for everyone, and trust me, that gets messy and insecure really fast. The modern, Google-recommended way is OS login. It's so much better. It just links SSH access directly to a user's Google identity and their IAM roles. Access is centralized, you can revoke it instantly, and you have a perfect audit trail.
Phew, that was a lot of ground to cover. So let's bring it all together with a quick checklist of the big ideas you absolutely need to remember. Okay, here it is. If you remember nothing else, remember this. 1. Least privilege, always. Give the minimum permissions needed. 2. Say no to static keys. Use modern patterns like workload identity and impersonation. 3. Use Secret Manager. Don't put secrets in your code or config files. 4. Defense in depth. Layer your security with things like IAP and network policies. And 5. Use the managed solutions. Let Google do the heavy lifting with tools like OS Login. And there you have it, a whirlwind tour of Section 4 for the ACE exam. But remember, this stuff isn't just about passing a test. It's about building secure, reliable systems. So the question I'll leave you with is, looking at this list, which one of these principles can you take and apply to something you're working on right now?